A square magnitude of A vector square magnitude of B square minus A dot B square. So A cross B has value square root of magnitude of A vector square magnitude of B vector square A dot B square. Prove that the point ABC with the position vector A vector, B vector and C vector respectively are collinear if and only if A cross B plus B cross C plus C cross A is equals to 0 vector. The points ABC are collinear. The points ABC are collinear if AB vector cross BC vector if the cross product of AB and BC is 0. Now position vector of B minus position vector of A, position vector of C minus position vector of B is 0. Take the cross product B vector cross C vector minus B vector cross B vector minus A vector cross C vector minus minus plus A cross B. B cross B has value 0, so B cross C negative of A cross C, we can write it as C cross A plus C cross A plus A cross B is equals to 0 vector. That is A vector cross B vector plus B vector cross C plus C vector cross A vector is equals to 0 vector. For any three vectors A, B, C, show that A vector cross B plus C plus B vector cross C plus A plus C vector cross A plus B is equals to 0 vector. Now take the left hand side, open the brackets, A cross B plus A cross C plus B cross C plus B cross A plus C cross A plus C cross B. A cross B plus A cross C plus B cross C. Instead of B cross A, that is equals to negative of A cross B, C cross A negative of A cross C, C cross B that is negative of B cross C. Now all the terms with opposite signs will get cancelled, so the answer is 0 vector. If A cross B, if A vector cross B vector is equals to C vector cross D vector and A cross C vector is equals to B cross D, show that A minus D vector, A vector minus D vector is parallel to B vector minus C vector, where A vector is not equals to D vector and B vector is not equals to C vector. We know that if there are two non-zero vectors, then they are parallel if and only if their cross product is 0. Their cross product is 0 vector. Therefore, to prove that A minus D vector is parallel to B minus C vector, it is sufficient to show that their cross product is 0. So we have to prove A vector minus D vector cross product with B vector minus C vector is 0 vector. Take the left hand side. A vector cross B minus A vector cross C minus D vector cross B minus minus plus D vector cross C. Now A cross B is equals to cross D. A cross C is equals to B cross D. Excuse me. Plus D vector cross C vector. We can write D vector cross C vector as negative of C cross D and minus D cross B as B cross D. All these vectors will get cancelled, so the answer is 0 vector. Let A vector, B vector, C vector be unit vectors such that A dot B is equals to A dot C is equals to 0 and the angle between B vector and C vector is pi by 6. Prove that A vector is equals to plus minus 2 into B cross C vector. A dot B is 0. It means A vector is perpendicular to B vector. A dot C is 0. So A vector is perpendicular to C vector. Now A vector is perpendicular to both B vector and C vector. Therefore, A vector is perpendicular to both B vector and C vector. Therefore, A vector is parallel to their cross product. A vector is parallel to their cross product. Let A vector is equals to lambda B vector cross C vector. Lambda B vector cross C vector. So magnitude of A vector is magnitude of lambda magnitude of B cross C. What is the formula for the cross product of two vectors? That is equals to magnitude of vector C, magnitude of C sine theta. Angle between B and C is given pi by 6. Magnitude of lambda, magnitude of B, magnitude of C. Sine pi by 6. Pi by 6 is 30 degree. Sine 30 degree has value 1 by 2. It is given that A, B, C are unit vectors. So magnitude of B and C is 1. So 1 by 2 lambda. This is the value of A vector. So lambda has value 2. So lambda is plus minus 2. Lambda is value plus minus 2. Put the value of lambda here. Magnitude of A vector is equals to plus minus 2 magnitude of B cross C, or we can say that A vector is equals to plus minus 2 B vector cross C vector. Next one. If A, B and C vectors are the three vectors such that A vector plus B vector plus C vector is equals to 0 vector, then prove that A vector cross B is equals to B cross C and is equals to C vector cross A vector. Now we have to show that these are equal, and it is given that A vector plus B plus C is 0 vector. First we want to find the term A cross B. First take the cross product with the vector A vector. A vector plus B plus C vector is equals to A vector cross 0 vector. Open the bracket. A cross A cross B, A cross C. This is 0. We know that cross product of the same vectors are 0. So we are left with A cross B plus A cross C is equals to 0 vector. We can write A cross C as negative of C cross A. When it goes on the right hand side, it becomes A cross B is equals to C cross A. Let this as equation 1. Now take the cross product of this with B vector. A plus B plus C. B vector cross A vector plus B cross B plus B cross C. Now cross product with the same terms is 0. So B cross A plus B cross C is 0 vector. Now we can write B cross A as negative of A cross B. When it goes on the right hand side, so B vector cross C vector, A cross B. Here we have find A cross B is equals to C cross A. Here A cross B is equals to B cross C. So from 1 and 2, what we get? A vector cross B vector is equals to B cross C is equals to C cross A. If A, B, C are three non-zero vectors such that A dot B cross C is 0, B vector and C vector are not parallel vectors, prove that A vector is lambda B plus mu C, where lambda and mu are scalars. If the dot product of this is 0, it means either A vector is 0 or B cross C vector is 0. That means A vector is, or dot product of two vectors is 0 if they are perpendicular to each other. So A vector is perpendicular to B cross C. If the cross product of two vectors is 0, it means they are parallel vectors. A vector is 0 or A vector is perpendicular to B cross C. If the cross product of two vectors is 0, it means that vectors are parallel vectors. But B cross C is vector. Write down. But B cross C is a vector perpendicular to plane containing B and C. Therefore, A vector perpendicular B cross C. Therefore, A vector perpendicular B cross C. A vector perpendicular है B cross C vector के. It means A lies in the plane of, A vector lies in plane of B vector and C vector, implies A vector, B vector, C vector are coplanar. अगर एक ही प्लेन में lie करते हैं, it means these vectors are coplanar vectors. Therefore, A vector, B vector, C vector are coplanar, implies A vector is lambda B plus mu C, where lambda and mu are scalars. Where lambda and mu are scalars. Prove that the normal to the plane containing 3 points whose position vectors are A vector, B vector and C vector lies in the direction B cross C plus C cross A plus A cross B. Write down. Let A, B, C be the points. Let A, B, C be the points with position vector A vector, B vector, C vector respectively, then AB vector cross AC vector is a vector normal to the plane containing the points A, B and C. Now AB vector cross AC vector, position vector of B minus position vector of A cross position vector of C minus position vector of A. So B cross C minus B cross A minus A cross C minus minus plus A cross A. A cross A has value 0. So B cross C, we can write negative of B cross A as positive A cross B and negative of A cross C as C cross A. So that is equals to A vector cross B vector plus B vector cross C plus C vector cross A vector. If A cross B is equals to A cross C, A vector is not equals to 0, B vector is not equals to C vector, show that B vector is C vector plus T A vector for some scalar T. It is given that A cross B is equals to A cross C. So we can write it as A cross B minus A cross C. A vector cross B vector minus C vector. If we take A vector common, A vector cross B minus C vector is 0. Cross product of two vectors are 0. Therefore either one vector is 0 or other vector is 0, or these are parallel vectors. It is given that A vector is not equals to 0. अगर हम इसको इक्वल रखते हैं 0 के, then B vector is equals to 0 is equals to C vector. But it is given that B vector is not equals to C vector and A vector is not equals to 0. So these two conditions are not satisfied. So the only left condition is A vector is parallel to B vector minus C vector. It means A vector is equals to B minus C T, where T is some scalar. Therefore, B vector is C vector plus T A vector. If A, B, C are the vectors such that A dot B is equals to A dot C, A cross B is equals to A cross C, A vector is not equals to 0 vector, then show that B vector is equals to C vector. A dot B is equals to A dot C. A vector dot B minus A dot C is equals to 0. We can write it as A vector dot B minus C is equals to 0. Dot product of two vectors are 0. If one vector is 0, two vector is equals to 0, or A vector is perpendicular to B minus C vector. Dot product of two vectors is equals to 0 when they are perpendicular. Now, it is given that A vector is not equals to 0, therefore it implies either B minus C vector is 0 or A vector is perpendicular to B minus C vector. Now, cross is A vector. Prove that A, B, C are mutually right angles such that modulus of B 1 and magnitude of C is magnitude of A vector. Now A vector cross B vector is equals to C vector and A vector is B cross C. It implies that